Sorry.
What's going to be in the square for a micro? The particles. Good. Okay. And what's going to be in the square for a macro?
Isn't that going to be the result?
No.
Or
Is
the-
it mechanical or thermal energy?
So not in the square. That's going to go in something else.
That goes in the arrow.
So it'll be like the scuba tank or the container or the tire. The container, the tire, the scuba tank. Okay, the fixed wall container or the movable wall container. Does that make sense with micro? If you're looking at the particles. If you want to be really spiffy, you'll say the particles at, whatever temperature they're at. Yeah, 293 Kelvin or whatever the temperature is at. Okay, but you don't have to. Particles is good enough. Okay, now, looking at these interaction types, only the things in the arrows, what are the only two arrows that we have to deal with right now? Mechanical and heat. Okay? So the only two, so circle those two. Okay? Mechanical and heat. Those are the only two that you have to worry about. All right? So, did you print out that micro-macro practice sheet? Did you print that out? Okay, so let me show. And if you didn't print it out, don't worry, because it's just a few words. Okay, so this here. All right? This here? Okay. All right. So, in the arrows, the input or the output, remember those, the arrows for the input or the output, we're either going to have mechanical energy or what's the other one we're going to have? Good. Heat energy. Okay. Or heat energy. Okay. Now, let's look at our first one. Our first one says, micro input output energy diagram, heating gas while volume changes. Heating gas while volume changes. Always start with the box. What's going to go in the box?
Particles.
Particles.
Particles, good. Okay, so particles.
We just write it, would you have to draw it?
Start with the box. It's either going to have particles in it or it's going to have the tire, the container, the scuba tank, the balloon, whatever the container is, okay, for a macro. All right.
Do we have to say what type of particles they are?
No,
Okay.
we're not going to get into that. Okay, now what does the question say?
Heating gas.
Heating gas while volume
Heating gas while volume changes. So what is the input? What's going to go in the arrow?
Heat energy.
Excellent. Heat energy. And it says, while heating gas, while the volume changes. How do you indicate while the volume changes? How do you indicate the volume changing?
Don't you run a line below particles and symbolize
So
it that
remember,
way?
the energy in is equal to the energy
Energy out.
plus energy changes. That's in your study guide, that's in the book, that's in a lot of places. All of this will be crystal clear to you when you leave here, I promise you. This morning was like, are you kidding me? That's all it is? I'm like, yeah, that's all it is. Okay?
I got it from these charts, even though I got some wrong, but
Mhm.
when you follow them,
So it says the volume changes. How are you going to indicate the volume changing? What does the volume changing mean?
Decrease, increase.
it's getting
the
bigger.
container's either going up or going
down.
down. You're
So
heating.
you'll
so
have an
it's
arrow
probably going up.
up.
Okay.
Increase in kinetic energy?
So you are going to have two things.
You have to-
Okay. What can only go in the arrows?
Mechanical.
Heat or mechanical? Which one is going to go in that arrow?
Mechanical.
Mechanical. You added heat to the particles, the volume changed. That's the output. Input is equal to output plus changes. What is the change? What is the change in the particles?
It's an increase in kinetic energy.
Kinetic energy.
Increase.
I have a question about that. Sometimes it's increase in average kinetic energy. What's the difference? Is it,
Always, when we take the kinetic energy of the molecules, we're taking the average of all the molecules.
so
So,
it doesn't matter
Yeah.
which one we
yeah. Okay? So you can stop now.